Number 59. Which of the following has two unpaired electrons? And then I see that it's like a multiple choice question. Magnesium is A, silicon B, sulfur C, and then you got D and E. All right, so we got to find out which one has two unpaired electrons. When they're talking about unpaired electrons, it seems like I have to draw something, right, in order to see this unpairing, quote unquote. When they're talking about unpaired or paired electrons, what they want you to draw is the orbital diagram. And orbital diagrams usually come from valence electrons. All right. Now, we've done plenty of questions with how to draw orbital diagrams previously in this chapter. So I think they're probably like 5 questions back. So if you haven't drawn an orbital diagram, go back and do those questions first, because this will kind of be like the quick version. But nonetheless, we have to draw an orbital diagram for magnesium, silicon, and sulfur, and then we just got to figure out which ones have two unpaired electrons. All right, so when we draw orbital diagrams, we have to draw them from their electron configuration, right? So we got to first, figure out how to draw electron configurations. This one I'm going to do the shorthand version, because unpaired electrons always come from the valence electrons, which are found in the outermost shell. So let's first find out the electron configuration for magnesium. Now remember, when you're doing this, the first two groups are where the s electrons are located. This is where your d electrons are located. This is where your p electrons, and then this is your f electrons. And remember, helium, when you're doing orbital diagrams and electron configuration, get rid of helium here, put it right next to hydrogen, because it's really a s, part of the s orbital, not the p's. All right, so magnesium is over here. Let's do the shorthand version, which means that we put the noble gas before magnesium in brackets. That means that we have all the electrons up until that noble gas. Now, the noble gas before magnesium will always be found in this group. The last group is where your noble gases are found. The noble gas before magnesium would be neon, right? So I can put neon in brackets. And then I just pick it up from there. Then I start with this period. So remember, it goes 1s, 2s. This would be the 3s. So this would be 3s2, because I have to pass both boxes. So that would be magnesium's configuration. Now, if I had to draw the orbital diagram for magnesium for its valence electrons, these are the valence electrons, the outermost shell. And remember, S only has one box, right? Because it has two max electrons, one box. Each box can only have a max of 2 electrons. So the P's would have 3 boxes because it has a max of 6 electrons. The D's would have 5 because it has a max of 10 electrons. And the F's would have 7 boxes because they have a max of 14 electrons. So here I'm going to draw one box, label it 3s, and it has 2 electrons. That's what the number in the upper right-hand corner signifies. So 1 electron, there's only one box, so it has to be paired. Now, if I look at this box, are these electrons paired or unpaired? They're paired together in a box, right? So these would be paired. So would magnesium have 2 unpaired electrons? Unpaired means that they wouldn't be together. There would be 2 electrons in 2 different boxes. So magnesium's out, right? That's paired. So that means that D is out as well. Let's now go to silicon. All right, well, shorthand version, silicon is right here. The noble gas before it is neon, once again. And now let's write out the electron configuration. It's still 3s2, but now we move over here. Remember, this starts the 2p, this is the 3p, so it would be 3p2. So when we draw silicon, we now have the S, which is one box, And then we have the 3p, which is 3 boxes. 1, 2, 3. This information right here should be memorized. It has to be memorized. Your teacher or professor, I don't think, would give you that hint on the test or quiz. So just memorize how many boxes for each shell, or each orbital, technically. So you have 2 electrons in the 3s, so that's 1, 2. But then you have 2 electrons in the p's, and remember, it's like the kids on the school bus. This is Aufbau's principle, right? If you have an electron here, where's the other electron going to go? It's not going to fit in the same seat, right, or the same box. If there's available seats here, it's going to want its own seat, so it would go here. Are these electrons paired or unpaired? These are unpaired. So, and there's 2. There's 1 here, and there's 1 here. So 2 unpaired electrons. So this would check out. Now we just got to figure out if sulfur is the same exact thing. So first let's do the electron configuration for sulfur. Sulfur is over here. So it basically would be neon. 3s2, but now 3p, you have to pass 4 boxes. 1, 2, 3, 4. So this would be 3p4. Let's draw the diagram for sulfur. You have 1 box for 3s, and you have 3 boxes for 3p. The 2 electrons are in 3s, and now you have a total of 4 electrons. So 1, 2, 3, 4. How many unpaired electrons are here? Oh, well, these are unpaired, right? And they're 2 unpaired. So this also would classify as 2 unpaired valence electrons. So this would check out as well, which means that the answer has to be both silicon and sulfur. So just know for this question, there's many different types of atoms that have 2 unpaired, 3 unpaired, 4 unpaired electrons, and so forth. You have to draw the orbital diagrams to see which ones they are. All right, guys? So, thank you for tuning in. Hopefully this helped. If it did, like the video, leave me a comment. And if you want to help the channel out, click subscribe. You'll also be getting all of our answers in your feed as they come out, which would help you guys on your tests or quizzes or homeworks. So, thank you so much for supporting us. I hope we are helping you guys. Take care now. See you later.